Alex.
Okay. Good evening, everyone, and welcome to this final part of this short but very intense workshop on embodied perspective on music and AI. And I would like to introduce the evening concert. We have the Optic fiber ensemble, which is primarily composed by our MCT students, master students in the program in Music Communication Technology from the Department of Musicology here at the University of Oslo. And our students have prepared two pieces, Autumn Leaves plus I Know Sunshine, a cover song mashup, and Telematic Tapes, which is an original composition. On stage, here we have Emin and Nino. And on the other side of the screen, sitting at RITMO, where we were earlier in the day, there is Masoud and Fabian. Technicians, Christian, Jack, Joseph, Ejma, and Alexander. And students are performing this concert as part of their final part of the course in telematic music, which is led by Alexander Tiedemann, that is the teacher of this course. So please give them a warm welcome.
The fallen leaves drift by the window. The autumn leaves of red and gold. I see your lips on summer kisses and a sunburned hands I used to hold. Since you went away, the days grow long, and soon I'll hear a winter sound. But I miss you most of all, my darling. And the autumn leaves start to fall. I see your lips on summer kisses and the sunburned hands I used to hold. Since you went away, the days grow long, and soon I'll hear a winter sound. But I miss you most of all, my darling. And the autumn leaves start to fall. Ain't no sunshine when she's gone. It's not warm when she's away. no sunshine when she's gone, and it's how she's saying I know, and she's always walking away. Ain't no sunshine when she's young, only darkness every day. Ain't no sunshine when she's gone, and it's how she's in a hole anytime she goes away. Anytime she goes away.
Hello everyone. Thank you for coming. Stefano, I also wanted to say a couple of words on behalf of my friends. We are music communication and technology master's students, and this is our end semester concert. You're all welcome. We are doing a lot of different things at the same time today, actually. We are giving a concert, but we're also doing an assignment now, which will be graded. We will be making music from quite different genres, and we'll be trying different instruments and techniques at the same time as well. We are excited to go into the second part, but first let me explain what's going on here. We are a group of people making music together, but half of us is in another building. And these technicians, and there's also another group of technicians in the other building as well, and they are connecting us through the network with the speed of the light, using low latency advanced communication technologies, and they are trying their best to make it close to a real life experience. So for the next 10-15 minutes, we'll be playing semi-improvised experimental kind of music that we've been working on for the last couple of weeks. Hope you enjoy that, and thank you very, very much for coming here today.
خبر شد ز ما نبود ما را زمان گر شکند ساز میشویم ساز میشویم ساز ساز ساز
Okay, thank you very much, guys. Thanks for the music, thanks for the concert, and perhaps we can give another round of applause also to the technicians on the other side. I don't know if they want to come in front of the camera. Perhaps you can tell them. Yeah. Okay, now it's time to move on with the third and final keynote speech of this workshop. Actually, it's going to be a keynote performance. I would like to introduce Koray Tayruloglu. Koray is a musician, an academy research fellow and lecturer at the Department of Art and Media at Aalto University School of Arts. He is the founder and head of Sound and Physical Interaction Research Group, coordinating research projects with interest, including embodied approaches to sonic interaction, new interfaces for musical expression, deep learning, and artificial intelligence technologies with audio. Since 2004, he has been also teaching workshops and courses introducing artistic strategies and methodologies for creative interactive music. Koray has been performing experimental music in collaboration as well as in solo performances in Europe, North America, and Australia. His work has been presented in important venues such as Ars Electronica, AI for Music Festival, STAME, Today's Art and Audio Art Festival. In 2018, he was awarded with a 5-year Academy of Finland Research Fellowship. And today, Koray is going to talk about communal, AI as a material, instrument, and other. So please give him a very warm welcome. as usual, when there's too many cables, there's always some troubleshooting to do, but we're actually ready. So let's give Koray another round of applause, and then he can begin.
Not the way it went. Sorry about that. All right, thank you. Well, there was some sound balance was not that much what we did earlier, so sorry about that. But I would like to now talk a little about this piece. All right. This communal is one of a set of compositions that we've been performing with Alterity musical instrument. Alterity is a new instrument that inherits a particular deep learning model for generating audio samples in real time and also navigates in the latent space while doing that. So in relation to this performance, I will also briefly discuss in what ways the composition actually describes a co-creation or co-creation between musician and the instrument. And then I will play the second part of the communal. Maybe one of the most interesting aspects of this composition is that, as you probably have noticed, that music gradually evolves into a continuous state of transformation until this transformation happens in the sound space of the instrument until the musician or the alterity finds an interesting point, a new point in the sound space, and that breaks the flow of the composition and puts music into a new transition. And that's a way that's how the music continuously changes and moves and transforms in this piece. And finding a new point in this instrument sound space means that musician and the instrument continuously negotiating on what the boundaries of timbre space will be, so that they work together to direct, suggest, and form a transitional musical narrative here. So it's a collective work together with me and Alterity, and that makes the instrument to be a co-creator of this work. And in this piece, the instrument has an opportunity to act autonomously. In fact, in various cases, it is expected to contradict what the musicians has been performing in order to create some new interesting musical events. But collective work or co-creating compositions are nothing new. Indeed, it's very at the heart of any music practice. I'm sure you have already watched this documentary movie. This image is from that particular scene, which many also finds it iconic, simply because it shows the composition process of one of the well-known songs of this band. But this scene also tells us something about the creative process of this composition. As such, it is a true co-creation with other musicians involved in the process. But I've already talked about this earlier as well, but maybe sometimes you might not be that much lucky with your co-creators' involvement in your particular part of the composition. But still, this is something we know about creative activity. This has been also discussed today as well. It is a social process emerging from interactions, dialogues, and conversations shared with others. It is a social process, even though we might think that we are individually alone on that particular moment, but it is an activity that it unfolds in and through social practices. And even it might be a common assumption to think about musicians, artists, isolating themselves from society or from everything else until the work is done. But creative work develops and exists in the wider context of its sociocultural environment. And here highlighting the role of others, like Alterity in this process. So this social dimension has been very much acknowledged in relevant creative practices, referring to the relationships between creative agents and to their environment. And in our specific context of music, then social dimension also plays a very crucial role. Social builds a space for expression of thoughts, ideas, for all the actors co-creatively participating in music. And when we mention all the actors, we also need to talk about non-human ones. This has also been discussed in various talks today and yesterday. Like humans, technologies do have certain agency, like entity, and our interactions with these new artifacts embody new, like in these new instruments, they embody new relations with technologies. Especially, that's also the reason why we have this workshop, but the current development in artificial intelligence technologies in the creative practices of musicians, instrument builders, they do show a wider spectrum of interest in forming technologies that have a certain musical agency, maybe even more autonomous entities. That also led us to rethink about what social is. Here, I guess we are resonating well with the ways Latour talks about the idea of agency. This was also discussed yesterday. Bruno Latour explains agency not only as a reserved term for human actors, but as anything that does modify a state of affairs by making a difference. So a musical instrument that supports building up a musical identity in a performance might fit in very well to this concept. And following the idea of modify a state of affairs by making a difference, then we can question whether the instrument makes a difference in the course of music making, and any of this difference could be recognized or not. If the answer is yes, then we can focus more on the instrument as agency, and that becomes a part of a social. And in this social, this means that all the actors, human musicians, and technology entities, they all exist naturally and continuously shifting their network of relationships in this social, which builds up an environment for co-creations. So what these ideas, such co-creation brings into our own music practice, in which we have been building new musical instruments, writing compositions, and performing with them. Our main intention in looking into social has been to understand our possible mutual cooperation with digital musical instruments. To understand how does mutual cooperation is defined considering the relational roles and interests that appear between non-human and human actors throughout their active involvement in music. So following these lines of thoughts, we had a chance to explore our interest in mutual cooperation through a digital musical instrument. So this is Alterity. It's a deformable, non-rigid musical instrument, so you can physically deform, tilt, bend, and throughout that you can explore its sound world. And in its sound synthesis part, we use a GAN model to generate audio samples in real time. GAN models demonstrate computationally advanced opportunities, especially for real-time performances. And these models can represent timbre as vector in high-dimensional space, and each vector point presents some of the audio features that comes from the data set. And most importantly, these models provide us a possibility to move along the interesting points in that space that belongs to the data set that we train, and then generate new sounds by just moving along the different points. And these generated sounds are new sounds that they do not exist in the data set, but of course they are obviously related. But it allows us to explore generating sounds that we haven't had heard before. So what we do after that in our instrument, we feed these generated audio samples into audio synthesis module, where the musicians control input manipulates the synthesis parameters. For this instrument, we developed GAN Space Synth. It's a hybrid architecture. So simply we brought together GAN Synth and GAN Space. GAN Synth is developed by Google Magenta team, but we applied a dimensionality reduction technique to GAN Synth, which gives us an opportunity to navigate in the GAN space in a more controlled manner rather than randomly just jumping back and forth in between different vector points. And another advantage that we use in the sound synthesis module is that we use GAN Space Synth batch synthesis to synthesize multiple sounds in one go. This comes with the GAN Synth structure. So we form a small sphere around the current position in the latent space, and then we spread 8 different points evenly on that sphere surface, resulting in 8 different vector points. So the idea here is that we synthesize like multiple small variations each time we move from one point to another point. So in this 8 audio samples, we also play 8 corresponding instances of granular synthesis. And in order to make all these things in real time, we use an external GPU. Otherwise, these things will not be possible to have. And so that the GAN synthesis and grain playback can trigger each other as often as, in our case, we can synthesize every 60 milliseconds, which is a real time for me. Implementing GAN Space Synth has provided us a new approach to music creation. So the instrument Alterity has been also developed to allow this GAN model to be further explored in music compositions. For example, we had a chance to have a studio session with Alterity and with 2 human musicians last March. I will play short video clips just to give you an idea what these studio sessions were about. And I will briefly talk about our social explorations after these studio sessions. Well, this was a different kind of practice for us. We never actually used alterity with another musician and in a different context. And maybe one of the biggest challenge was here what we had in the studio session, that the autonomous features of the alterity. These autonomous features are a bit different than comparing to other autonomous instruments. Those generate counter-musical actions in response to human musicians' input, but instead, alterity monitors the interaction rate of the sound-generated inputs and then autonomously moves along the latent space, which continuously also change the timbre characteristics of the samples. And when it moves, this actually results in a transition between vector points. So what do we mean with that? That when we move between vector points, this means interpolating, so that it doesn't jump from one point to another, but actually it continuously synthesizes each steps. And in that way, it creates its own autonomous translation of sounds, which builds a very characteristics of this instrument. I will show you what we mean with interpolating, and this video can demonstrate how alterity moves along the latent space and synthesize the sounds at the same time. I guess you could clearly hear how the timbre features of the generated samples were changing when moving from one point to another. And this transition between the points in the sound space, actually it creates an interesting musical interaction between the instrument and the human musician. As I have mentioned before, but what we felt was as if like we were throwing in the space of a musical universe with continuously transforming cluster of sound. And such entity has been very well recognized and acknowledged during our studio sessions, and which ended up building new interactions and new ways of co-creations with alterity, which simply makes alterity to be part of this social rather than an object that is removed from the flow of the musical activity. One of the important findings based on our own experience during the studio session is that this musical interaction between the musicians and instrument turned out to be a continuous iterations of making new relationships, which eventually, we actually spent 2 days only to really get well with each other, to understand what each of us had been doing. And that turned into more like an assembling, that you also use the word today, and a collective. And at the end, as musicians, we did not take the instrument as an instrument but to be played, but then as an agent that is other with autonomous traits to be heard. And in that sense, this builds up a social and collective and music performance to be a mutual cooperation. So our social and collective findings might be seen as a performance perspective, but it allowed us to work together with alterity and compose music in different music contexts. Now I would like to play the second part, which will be a little shorter, but hopefully what I try to describe would even more make sense. Then I guess we can have more questions after that. But for that, I will load another model. So this will take less than a minute. Thank you.
Okay, so thank you, Koray, for the interesting talk and the performance. And we have time for questions before we move to the final act of the workshop. So does anyone has any question or comment for Koray?
Hey, thanks for the performance and the talk. It's great. I was wondering about the choice to have it kind of low to the ground, if that's a choice. Like you kind of have this posture where you're kind of stooping over the alterity. I was wondering about that choice.
Well, it needs to be a bit stable. That's also one of the reasons why it's on the, but also I can grab like in a more convenient way
Gotcha.
for me.
So just kind of a mechanical thing.
Yes, and also the control parameters for the synthesis that you really need to put a good effort. So that you really need to bend. That gives a wider possibilities to play around with the granular synthesis features, actually.
Thanks.
I have a quick one. I'm just curious about the construction of the interface itself. What are you interacting with when you're bending it and pulling it and twisting it?
Well, this shape came up with the idea that we were talking about when we were talking about gunlet and space with multidimensional, 256, how we can actually represent that as something that we can even understand. This came out with an idea that when you have a paper, for example, if you fold it in a different ways, then you can actually you can see like many other dimensions as well. So the folded shape came from there. But what happens that we have sensors inside this material. This is like a polyurethane material, like a car tires, how they make. So we make a cast that has, well, we first milled it with like some wooden structure so that we can have all these shapes on that wood piece. Then through using that wood, we make a silicone cast. So silicone cast has this space inside, and we put sensors before we put the polyurethane materials. So the sensors actually, they fly in the air in between the silicone. So when we put these liquids, so that it just covers the whole sensors in it. It has eight different places a band sensor. That's how we can use this twist, bending, and sense that and send it to sound synthesis.
You just answered my question, so someone else can go.
Okay, any more questions?
Curious about your thoughts on this kind of bend push kind of a surface. I mean, you explained in a way the paper folding model representing the GAN space, but what about the interaction and whatever?
Yeah, well, embodiment has been also influencing us, all the embodied interaction approaches that all our instruments, they are handheld. So that's how we are interacting with them. So that has been our initial idea, that the instrument will have something that we can control using our hand gestures and bodily movements as well. That is the reason we also made this stiffness. It's not that much like soft, for example. So you really need to use, especially these two wings, we call them. You really need to use your whole body to, interact with that. So that's main reason why it's this shape and this material.
Thanks for the performance and the keynote. It was really, really nice. I was wondering if you could tell a bit more. I wasn't completely clear on the behavior of the agent as it's moving through the latent space. If you could just tell us a little bit more about how it's making the decisions and everything.
Yeah, it continuously it monitors musicians' input as like what we call it interaction rate. So how often you actually try to manipulate a sound parameter. And based on that, it decides to, this comes from the previous composition we wrote, we call it uncertainty. So it actually feels like you are very confident in that place because you are really in a way enjoying, and it tries to take you to another direction in this space. But unlike the previous composition, now we can negotiate. So that if I do not really like that place, so I can get back to wherever, or then Alterity can also suggest us to go somewhere else. And that becomes like a part of a composition as well.
Any more question? Okay, there.
Hi. I was wondering, maybe you said this and I missed it, but you were doing something on some tablet or something? You were like changing scenes?
Yeah, this is our negotiation platform with Alterity.
Okay.
So I can see which direction it's going. And we also have some predefined points in the space as well. And that's a part of the composition. So I know how the composition could develop, but I don't know how we can go there. So if that's part of the negotiation with Alterity.
And why did you decide to have it as an independent thing?
As an autonomous instrument?
No, why is it not embedded in the instrument or next to it?
Yeah,
why do you have an external device that you need to communicate with your instrument?
We were actually planning to, might be easier actually to put it as like a part of the interface here as well, but we didn't really have that much time, so it was easy for us to have something with OSC interface that we can communicate.
Do you think so you were talking about all of these aspects of sociality, does it, maybe I'm trying to like go to like being like the picky question, but like, do you think it changes anything, the fact that you have to, because from the outside it's sometimes like you're going outside to come back in to change something and come back in. Do you think it changes anything in your performance, the fact that it's outside?
I don't know. I got used to it actually. I really don't think that much that I'm going out and coming in. But when you are in the playing mode, you don't really think about, you just focus on the sound.
Yeah.
And this just gives you an idea like, okay, we are going to that direction, if I'm happy with that or not. But I didn't think about that. I was going out and coming back in.
Okay, also, this really reminds me of course, Magnussen's book about symbolic thinking. Like, that looks very symbolic parameters. And you kind of change from this like very embodied touch feel to the symbolic, and you are like really like what he describes, like just thinking your modes of relating to the instruments. I think it's very interesting. Yeah, thank you.
Yeah.
Yeah. Thank you. I just have a question, maybe follow up on that sort of, but is there a notion of risk or failure there? I mean, can the interaction stop eventually? Or?
Yes, there is. Especially in latent space, there could be some dead points. Actually, that's where I did in the first performance. I did catch a place where it eventually, there wasn't any sample to synthesize. So that's one part. And that's a failure, actually, because this means that we didn't train the model properly, so that it didn't really fulfill all the dimensions in the latent space.
Hey, one more from me. I'm struck by something very, very strange, but in the slide that you have up, you cite the data sets that you've used.
Yes.
I've never seen anyone do that.
Yeah, I think, yeah.
Can you say a little bit about what your relationships are to these data sets and why you thought it was important to include them in the program notes, I guess you would call this?
Yeah, yeah. I think, well, this has been also discussed. The data set has been, data is the heart of everything in this deep learning model. And, well, many ethical questions also has been raised during when these models have been more available for us. Responsible AI has been very much mentioned in the field. And that's one of the things that you really need to tell which data set, whose data set are you using. And these are our data sets. We name them based on what they actually also mean to us. In the first data set, I call it early 2000. It's actually the performance recordings of what I have been playing around early 2000. So I use those as like an audio set. I prepared audio data set from them and created the model. Second one is Miranda, our research assistant. We are also teaching a course, deep learning of audio, and we provide these ready-made models to our students. And she was also using her own performance recordings. She called it PRU. And second data set, second model was actually based on this PRU data set. So I think it is important to mention what you are using, whose data set you are using in these sort of situations.
I agree completely, but it's nice to see some examples of practice of how to actually...
Yeah.
Yeah, I wonder about your interaction with the movement in the latent space, and when you're performing, I guess that there should be some kind of prediction for the movement of the latent space for you, and then you decide how to interact with the instrument. But I wonder if that prediction can also be the part of the instrument that, okay, it predicts your next movement and then decide the next action, actually. So in that way, I guess the interaction would be, I don't know, more
fluid.
Kind of, yeah, I don't know.
That's a good idea. I mean, yeah, I can predict because I know the data set, and in a way that's the reason why we use this dimensionality reduction technique, so we know in a way like how we can navigate in this data set in a more controlled manner. But Alterity doesn't. That's true that it doesn't really predict as what the next step will be. Just more improvised in a way. But that could be, well, we are working in another model at the moment. There's nothing to do with the Alterity, but that has more prediction on human input as well.
So, do you think it's possible, or kind of, because it's kind of like improvised performance? So
it could be possible, of course, but it has not been our intention, and yeah.
I guess I'm 2 questions back. Someone asked about the failure of the system, and you were saying that the latent space embedding is missing.
Yeah.
Vectors aren't, but how is that a failure and not kind of the agentiality of the instrument, or how?
Yeah, that's a good question. But I mean, it could be both. But in a failure, in a way that when we train the model, we make our parameters so that the latent space will be fully covered, and with different layers even. Like, so that's actually, we might call it as failure, because that has been our intention to fully explore the latent space. So if we couldn't do that, then it could be called a failure. But if you could flip it around, then that could be an intention as well. So you could have dead spaces that could be part of your performances.
Yeah, I'm also particularly interested in the interaction part with the instrument, because like I look at it, and before the performance I came and touched it, and like it's not easy to understand what it does, you know, like how it's mapped, like the bodily input towards wherever it's mapped. So I'm just curious to hear more about, like you said that there are some wings, there are some different, you know, dimensions. Like sometimes you bend the bottom part, sometimes you know how you interact with it, and like what's the learnability like as an interface. Like, can you tell a bit more about that part?
What I briefly talked about is batch size 8, that actually defines the audio samples, how they are mapped to each point where we can actually change the parameters. So that once we are in a particular space, it makes a sphere around. So it brings a tiny variations so that each of these samples are a bit different. And this makes it, and also they are, maybe you can put it, and they are also a bit different, but the pitch also comes with the timbre characteristics of each sample.
But sorry, like what I'm curious about, like for instance, when you change from one position to the other, it's almost random, or you just know that okay, now I should go to that point, like. For instance, when playing guitar, for instance, you know that you want.
Yeah, they are tuned. I know that these will be the lower ones, and then these will be the higher. But still, when I move around, well, that has this like a relationship. Yeah. But as the interaction, basic, we have several. I don't remember how which was, like in the like basic granular parameters, index, velocity, and the duration. But we have mapped so that your single input actually changes all of them in a different ratio. So that also brings a good dynamic structure instead of having one-to-one map.
Yeah.
So one-to-many, but in a more relation, in a ratio, like a more particular ratio. Then it gives you, for example, if you give like a more, now we are moving in the latent space, but if you give more pressure, then you open up the grain sizes and it becomes like a more like a full sound. But if you have like small variations in your input, then you play around with like a small grain sizes.
Okay. We have time for, one more question.
Okay, thank you. This is better, good. Yeah. I enjoyed so much the organic part of your performance, because I really felt you melted in with the shape and the form, and very nice. And could I ask you a bit about your thoughts about the colors of the music? I mean, the sound that you chose, and maybe something about why they are there, and because
that's the reason also why we are using our own data set. This was also mentioned earlier in AI and Music Festival last year. while it brings up totally new sounds that nobody has ever heard before, but also because we are using our own data set, it also connects to us in a different way. So I played these things with this data set early 2000, and now they appear in this performance, in this composition again, but in a totally different forms. It was really exciting to hear when we first trained, which actually really also, in a way, overlaps with our main aesthetic interest in these instruments, how they should sound. I mean, this sound, that's, and how it evolves into, this is something more maybe personal, how we enjoy. But we didn't know how it would sound. And we also use many different types of audio data set. And the model did not really behave as it behaved to this type of data. So that's also something maybe related, so that this model maybe works better in this type of sounds. Maybe, for example, if there will be a single timbre sounds, like maybe only fluid sounds with different pitch, maybe then we would not have this sort of variations in different points.
If I may say, I feel this like your instrument is speaking.
Yeah.
Yeah, very much so, because it looks like the sound.
Right, thank you.
Okay, thank you very much. Thank you, Garai.
Great, thank you.
And we need a couple of minutes to prepare the stage, and then we'll move on with the final panel session. grand finale of this workshop on embodied perspective on music and AI. So I would like to give you a quick introduction of the member of the panel that we have today. We have Sarah Fidley-Alaoui, Associate Professor at Linz Université Paris-Calais, and ex situ INRIA research team in interaction design. Then we have Sofiane Audry, Professor at the School of Media at the University of Quebec, Montreal, and co-director of the Hexagram Network for Research Creation in Art, Culture, and Technology. Koray Tarilou, Academy Research Fellow and Lecturer at the Department of Art, Media of Aalto University School of Arts, Helsinki. And then we have Benedict Wallace, PhD Fellow at the Department of Informatics, University of Oslo, and at the RITMO Center for Interdisciplinary Studies in Rhythm, Time and Motion, and Alexander Jensenius, Professor at the Department of Musicology, University of Oslo, and also Director of RITMO Center for Interdisciplinary Studies in Rhythm, Time and Motion. So, welcome. So the topic for this final panel discussion is how can we make music with AI in future, also given that the meaning of making music may have different meaning. It can be performing, it can be composition, and anything in the between. I think that during this 2 days workshop, we've seen a lot of projects, ongoing works, which perhaps can give us some projection or idea of how things would be in future, but would be great to hear your take on this. Who wishes to start? Alexander.
Well, I can start with saying something. So last year, some of you may have heard this news about Frank Sinatra being put into an AI kind of like thing, and then you had lots of Frank Sinatra music, kind of new Frank Sinatra music made by this deep learning model. And then a lot of journalists called me, and I was on the radio several weeks at a time, kind of talking about AI and music. And what was interesting was that for many people, using AI to generate music was an entirely new thing. And I think it's nowadays, in these last few years, people have been starting to talk about it more generally. But for us working in the field, we know that, this has been going on for decades, even centuries, if you think about rule-based systems, a long time ago. It's just been an evolution. People have been making music with AI for a long period of time, and will continue to do so in the future. It's just more about how to do it, I think. Personally, I got into these things in the early 2000s. I was working with David Wessel at University of California, Berkeley, and was training these 10 neural networks, which was entirely new at the time, with timbre models, early models of what you have been showing a very fancy ways of now. But still, the idea, even at that time, like 20 years ago, we were training networks with timbre-based systems. So that's been going on for a while, and I think there is so much potential there, and we shouldn't really be afraid of it. We should really embrace the possibilities of this. That's kind of what I've been trying to tell to everyone, that they're kind of afraid that robots will take over the world. I try to say that just calm down, robots will not take over the world just yet. They are quite stupid, but together with the machines, we can kind of do interesting music also in the future.
Well, about this robots taking the world, we had a similar kind of event a week before in Helsinki, and this was also another question. There is always like a fear about these things, and I'm going to repeat what I said there as well, but maybe like we are a generation of unfulfilled promises of future. We all grew up with motor and robots taking over the world, with flying cars and all. But then when we came to 2020, we just learned how to wash our hands properly. So I think this is something that very human aspect of any human activity. You cannot really predict that the humans will not be involved. Music is a human activity. But yes, AI definitely brings new opportunities. And can you imagine how you can actually synthesize this kind of sounds, which actually AI makes this, in a way, more available to us? And yes, you're right. I mean, AI music has been an active research field over the years. But I guess the main difference now, since 2018, especially in audio domain, these tools began to be available and accessible for us. And in the languages that we can actually put our hands and do our practices with that. So I don't think that we can really predict future as they did earlier. They tried to do that earlier as well. But I think we can just practice. So by doing, we can get to the future and we can see how AI music could be possible. What do you think?
Sarah?
I don't know if my micro, something about it, not coming from the music domain per se, but having been a user of machine learning algorithms for a while, it is true that we've been playing around with these things for longer than the media is really advertising about it, and it makes it sound like a new hype thing, whereas, you know, academics and I guess also practitioners have been getting their hands dirty with it for much longer. So yeah, there is like this double discourse thing, but it's a trend to do that with technology. I feel like anytime like industries or try to claim novelty over some kind of technology, whereas academics have been playing with it for like 20 years or so. But in terms of like optimism about what AI brings in, I have like almost a love-hate relationship with it, like a cautious optimism, I would say. I like the opportunities that it brings when we're not trying so hard to make it fit into what humans do well and like to do. I like when it actually is surprising us, even like decentering the practice, bringing in different perspectives, like making some impossible things perhaps more attainable or explorables. And that, I think, is really interesting with what AI allows us to do, and especially these kind of black boxy models that you don't quite understand, but yet you can really play with and try and mingle and, as you were saying, apprivoiser, like try to tame down. But I stay cautious with, like, it's a slippery slope and very quickly can become this kind of discourse of like technology having this superpower, enabling creativity and so on, which I think is a discourse that I feel uncomfortable with. And so, like, where do you place that kind of collaboration, I think is a very, like, subtle place. Yeah.
Yeah, I guess my impression is just in sort of the brief span of time that I've been doing my master's and my PhD, it has changed so much. But just like the last 6 years, things have changed a lot. And I think what I see is sort of this it is these aspects of like when we hear Frank Sinatra again, or when suddenly you have these prompt-based generative models that produce something seemingly sort of completely separated from the human process of creating. It's just there at sort of your fingertips. That seems to create a lot more fear and strong reactions from maybe particularly creative practitioners, and maybe sort of for good reason. At the same time, I remember sort of my initial thoughts getting into the field of creativity and AI and creativity and programming. It was this sort of ideal imagined future was that it would make the process of creating things easier for people who weren't trained as a cellist or had, you know, this access to resources or training, and that people who couldn't draw could now create beautiful pieces of the art maybe in the future. And now we're sort of there, and it's maybe not exactly what we expected and a bit more scary. Yeah.
Yeah, these are all very interesting perspectives, and since the beginning of this workshop, I really enjoyed all the things I saw and all the conversation we had. It really got me thinking and really making connections with what you know. I mean, like, as an academic, sometimes you know, you read stuff and then you say things and things go fast. You don't necessarily always anchor that into you know, actual conversations. And the thing that I want to say is that if we're talking about the future of AI and music, is that one thing I observe is that here, as a community, you know, we seem to share a lot of perspectives over AI and creativity that are very different from the mainstream, let's say, or what tries to act or present itself as the mainstream. And it's a perspective that's much more humble in a way in terms of the technology, and that's because we've experienced it directly, and so we know that it has a lot of possibilities, but also a lot of limitations that you can kind of have to also live with the fact that if you give autonomy to systems, then you have to live with that, right? They're not going to behave the way that you want. Yeah. And where I want to go with that is that just connecting with the fact that we've, you know, what I was saying today and what has been said by you and you and like a lot of people here is how art and music are situated practices in, you know, they're situated in the social. And I think that perhaps what we can contribute, you know, as the creative communities, is to reimagine what AI can be as you know, as something that's and it won't be the only narrative and it won't be the only thing, and that's okay. But AI needs to be cannot just belong to the industry, because don't forget that it's a field of research that's been going on for a long time, which for most of its history has been quite abandoned and not really cared about by the commercial sector. And it went through a lot of investment from artists and from public research. I mean, when we were talking about the early 2000s, you know, and I did my master's in the early 2000s, I was working on trying to accelerate, my master's project was about accelerating the training of a huge neural network language model. And at that time, nobody thought that was a good idea. People thought that it was a stupid idea to make neural networks language models because it was so complicated and like it would never happen, it would never work. And I mean, like, okay, like, you know the rest of the story. And probably that, you know, even Yoshua Bengio, when he received the Turing Award, said something to the effect of, you know, if you want to do the next step of research in whatever field you are, you should not go towards what the mainstream is. And he said, right now, this is deep learning. So he basically said, like, if you want to go to the next step of AI, maybe you should not do deep learning. And I think that, you know, just circling back on what I was saying, I think that it's important that different communities reappropriate AI in their own way, because it's a set of approaches, ways of thinking that belong to humanity. They belong to the public domain. And I also, and I'll finish with that, you know, connected to this, is that I really invite you to also look at how non-Western, non-white, mainstream communities have also approached these questions, such as Aboriginal communities and Black communities too. There's some Stephanie Dinkins, for example, who made this really interesting early work with AI training. Speech generators based on histories from her own family and Black writing and things like that, just as a way to, again, kind of bring back to the community and reimagine really what AI could be from a human and community perspective. So I think maybe, to me, this is where the future of AI and music would be, is just to not care too much about what is going on and just continue to develop our own perspective, our own approaches to AI. And it's part of AI. There is not one form of AI that's good and the other is not, you know. So.
Thank you, everyone. And I'll continue asking another question. I mean, as few of you mentioned, I mean, this music and AI, music and machine learning variety of application, they're not very recent. They've been around for a couple of decades at least. But despite this, to a certain extent, we can say that the impact on the community of musicians and performers and composers and anything in between is still quite limited. Mm-hmm. And those very few examples of, let's say, music and AI tools that are available, most of them are based on machine learning, deep learning, and the most exciting component of machine learning has been taken out. So the learning part has been taken out. They just get a model, use it. And in this community, very often we praise the fact that we can work with very small data sets, personalized data set, how important it is to do an online training, and personalize. And it seems that what, on the other side, we are giving to the community that is not part of this kind of like small academic or research bubble, they're getting something very different. So I don't know, what can we do as a community to address this issue?
Yeah.
Tough question.
Maybe say a few things about that. I think that there is indeed limited access to technology in the practice, in the field work, simply because there are other conditions that I think artists are dealing with in order to produce work, and the extent of time and dedication that it takes to actually play with these type of technology makes it a little bit out of reach, as well as the type of setup that it requires, like some very concrete things about using this kind of technology, having large servers, very optimal machines, building some skills, and just the patience to mingle these parameters and try them out, I think makes it quite exclusive technology for now. We've been trying to do a lot of interactive machine learning in order to kind of like reverse that kind of tendency and allow or give people or practitioners more agency, so that they can actually train these models with their own data, even if they don't necessarily understand what's behind it, and also build models that are a little more transparent so that you know what's going on when you're actually training these models, and like give some representations out there. Obviously, it's more difficult with these black boxy ones. But it's always been a struggle, first of all, to make anything come out of academia and be really at the level of usability that can actually be used by people outside of really just experimentations and kind of like prototyping with the people. And we don't have that level of engineering and to be able to sustain these technologies for a longer time, which would be useful. So that's where industries come the then they have a different agenda. There's like business coming into play. So the the whole digital culture is really complex because there's so many agents and so many things that come to place. I think with AI, that's also the case. And with these models, that's also the case. So I don't have that many. I think perhaps Wikinator is one of those that has been the most extensively used by practitioners, but there was a lot of dedication from the research, from Rebecca and her collaborators to maintain that and like really push it forward and so on. So that's definitely kind of a problem, and that's one of the reasons why, I feel like in this field, academics somehow are overpowered by industry, and that all of the state-of-the-art stuff comes from these big companies, and then I see a lot of studies about models that the company produce, so that because there isn't the scalability of it is really difficult to achieve. So there's that, and then there's just the thing that performance artists are poor, really. Like they can't really afford to spend that much time with that kind of questions. I think what we're doing here is really like imagining a state of things that might be possible in maybe 20 years. And there's always this latency between what we're doing as academics and between real life outside of that bubble, as you said. And I think that takes some time, takes a little bit of time. So we're already in the future, really, in a way. So I'm not going to speculate for 20 more years.
Yeah, but I think that's an exciting point. Like I'm excited to see the next sort of generation, those who will have grown up with this being as accessible as it is today, and then even more accessible, presumably, in the years to come. Like growing up with a guitar or a piano in your household, if instead that is growing up with a certain level of technology that is accessible to you. And now that we, at least in this country, we're moving towards sort of having more programming in schools and for kids. And I think as someone who started programming late in my life, I was an adult by the time I started programming. I definitely can relate to the feeling of feeling like that is a sort of a walled-in thing that is too difficult for me to do, and like if you feel like you're more of an artistic person, then maybe that's an even scarier sort of wall to try and approach and let alone try and break down and make sense of. So I think breaking down that idea of technology and programming being something niche and maybe for boys and maybe these kind of things, that having that shift might also affect how these things are used. So, but yeah, seeing how your kids' kids, what they end up producing with AI will be interesting.
Yeah, just to follow up here, it's also, when we're working in universities, as you say, things take a long time, and one of the most important products I think that we are producing as university teachers, that's kind of graduate students that can go out and do things. but that it takes a long time to have students come through a university education and also to go out and do interesting things. But I think it's important for us as a community to also work not against, I should say, but do different things than what the big companies do, because the big companies do these massive things with a lot of inherited bias, as you talked about. When you train with a certain particular type of data set, that's basically what you get. And we know that there are lots and lots of bias in the data sets that are used for training today. So I think if we want to go to a point where we look at embodiment again, personal relationships between yourself and the technology, etc., we need to really scale down. We need to look at individual data sets, as you were presenting also in your work, right? Telling about, okay, this is actually the data that I've been using, and this is the model I've been building, etc., and this is my thing that I can work with, and you do your thing, and you do your thing, etc. And it's kind of that's how the world works. We are individual people. We're sitting here and we're communicating with each other, right? We're not trying to kind of make one massive person out of us. Like perhaps the tendency in the industry is to make one massive kind of machine learning algorithm that can do it all with everything that's ever been in there. And I don't think that's the way to go, really. I believe in kind of network-based systems where you have individual actors. And exploring that more, I think, is our job, to figure out how can we do it and kind of test it out, fail, test it out again, fail again. But kind of these prototypes that we are all developing and taking part of, and if we also share data, share kind of source code for these things, etc., that's part of this development that will be an alternative to kind of all the industry stuff that is happening.
Does anyone remember Basic Stamp? All right. You know, that was one of the first microcontrollers that we had a chance to put our hands, but it was super expensive for a student at that time, over $100. And also it was sort of like a monopoly. With their sensors, you have to get their sensors to use. But then Arduino came. Then the Arduino became like an electric guitar for that. I think similar kind of things is, yes, when I said that now it's more accessible, but in a way that on the code part, so we can use already trained models. But I think that would be maybe a research direction that we can also focus if we would like to have these technologies, like turn that to be electric guitar, where every household could hand. So that then we can start questioning, do we really need these big data sets for training? You know, Rebecca also questions a lot about the small data set methods, but also like a hardware wise as well. Why do we, I mean, yes, the GPU is sort of necessary for the whole training and generating, but I think more a research direction, moving a little away from the industry partners and focusing on more sustainable AI, meaning that it could be available for everyone. I think that could also help us to predict what kind of things could happen in the future as well, if these things could be available, properly available to anyone.
Yeah, just going in the same direction. I mean, the problem we have with the innovation in this field, it's not just us, it's the whole field. Most innovation in AI is made in the industry, not in even academic labs. Like, that's the situation today, but once again, yes, it's like it's a certain kind of innovation that's based on what the industry has, which are like large amounts of data that they stole from everybody, access to huge computing resources. And yeah, they make some really, really impressive things with that. Let's give it to them, and that's probably, you know, like, over the time, probably with, you know, antitrust laws and everything, we'll have access to some of that. But that's just back to my point earlier. That's just one part of AI, and like, it's just one piece of the puzzle, you know, and it's just one approach. And where we can maybe do things differently, and this is maybe something just as kind of just something to think about for our community, is to maybe stop trying to push the technological boundaries in terms of, you know, inventing new algorithms and I mean, do it, but in a more collaborative manner, because I feel like the issue that we have sometimes is that we each kind of work in our own space, and so there's people who create some really interesting tools, for example, but they don't really have anyone using them. There's artists on the other side who use AI, say they use AI, but they use, you know, they made just a piece of code and they don't really know what they're doing, and they don't know that there's some really interesting things that maybe exist out there. So I think we need to work together more, because that's the strength that we have. That's because we're all interested in, you know, as I said earlier, we're all outsiders here, but that's we're happy to be, because like we like to work across disciplines, and that's something that I think that's a strength that we need to use more. So.
Thank you. And yeah. Just to follow up a little bit on what Sarah said, I mean, I think you say that the technology very often is exclusive, which means that we're leaving someone outside of this. So perhaps we should collaborate. rather than pushing forward the technological boundaries, squeezing out performances and getting better and better system, we can actually try to make this system more accessible and inclusive. So perhaps this is...
Yeah, and that's what better means. It's just not just means to have 1% more precision on a certain task. You know, it can mean making better art. It can mean making art that is more corresponds to feminist values, to more inclusive values, that is more accessible, that is more that people can, that is more open-ended. You know, those are also important values, and the industry doesn't care much about that, but they're important. They're especially important for our field, for creators, you know. Like, the thing is that, and this is a space where the industry, for them, is hard to compete because they want people to use their products, and what they propose with these for example, these really big models is the side effect is that it becomes homogeneous. You know, it's hard to bring something original and personal. You know, it creates more of the same thing, and like that was the argument. That was the reason. The original. Sorry, I keep coming back with this example because I find it fascinating. But that's the reason why Nicolas Baginski chose to create the Three Sirens, is that he knew. Back in the late 1980s, there were the first experiments, first publications on neural networks that were trained on scores. And there was this famous publication where they showed that they could generate scores of blues based on existing scores of blues. And Baginski read those articles and said, well, that's not interesting to me. Because it's just, the only thing it can produce is more of the things that are expected. I want to learn something about music. I want to invent, and I'm not going to do it. I'm going to create robots that are going to invent a new kind of music, and I'm going to listen to that music and see what it tells me. You know, I want to learn something, and so just like this is maybe the space where we can operate, and it's a very important space, you know, because it's a space where new ideas can really emerge, and we can, and I really think it's a matter of survival. I really think that artists and musicians and composers and writers are the antibodies of culture, you know. They're able to just reveal things, just like create new language for things that we don't know how to express yet, and just reveal things that things and ways of acting in the world. And if we don't have that, then we're doomed, because we're just going to reproduce the status quo, and we're just going to consolidate existing structures of power.
Thank you. We have only 10 minutes left. I mean, I think we can go on for hours and hours discussing about this. I would like to open for question, if someone would like to ask a question to the panel.
Hi, this is a question I've been thinking about, and I want to get some thoughts from you. I've been thinking about how AI can actually change, maybe change live electronic music performance. I like electronic music performance, and it takes various shapes, but mainstream, it's usually someone sitting behind a computer. And yeah, we talked that AI, it's in this workshop, like the abstract, it talked about how it's not only about making audio, right? It's about embodying things. And yeah, I wonder how that might look like. This is a question I've been thinking a lot about. Like, is there more possibilities to electronic music that's sitting behind a computer? Or making gestures, like, yeah, you can make gestures, right? But gestures that make sound. And yeah, you do lots of motion capture here. And I was wondering how that might look like in the future.
Well, I could try to say something about it. Well, I think, first of all, that it's again, going back to this idea of thinking about AI as being one big machine with one big output, I think that if you look at how the non-AI world works, I mean, we are individuals, we are working with we have different objects around that make sound, etc., and that sound is localized. So I think, from my perspective at least, then also with electronic music, I like to call it electroacoustic music because we often forget about the sound part of it, and we have kind of all these so-called digital musical instruments that you plug into something and it goes out on 2 big PA speakers, and it's a very kind of this kind of disembodiment between what you do and also the sound itself. I'm not even talking about the mapping here, but just kind of the location of where the sound is coming from. So personally, in my instruments and things I've been working on in the last few years, I've going back to the idea of thinking about the sound should come from where you kind of produce it in a way, so that you can also physically feel the vibrations of the sound, so that you kind of get back to this kind of physicality of resonating objects, etc. And personally, I think that's a much more interesting approach where you get back to the same kind of feeling of playing something as you have with an acoustic instrument. That's not to say that we should replicate acoustic instruments, but it's a very different way of thinking about electroacoustic instruments than we typically do today. And then also spreading these around, if you have multiple of them, then you would get a kind of very different physicality of the whole performance. And then adding some robots on top of that, etc., that can do something, etc., as you've seen probably examples of at RITMO with drumming robots and other types of things, etc. I mean, it's kind of the world is complex, and I think we need to build complexity again, add complexity back into the electronic world. Sometimes we try to simplify it, and well, it's complex on the inside, but we kind of try to make it, it's complex on the inside, but try to make it simple on the outside. I think we should try to do it the other way around, which should be kind of small, simple things that together add up to kind of a big complexity, and personally, I think that's much more interesting.
Thank you.
Well, I think we have different kind of relationships with live or electroacoustic music as well. One way of approaching is that, yes, embodied interaction or embodiment plays a crucial role. There are also like other ways, like for example, we have live coding, and that's a particular practice which actually emerged from the other practices. But it has more symbolic relationship, for example, with the technology. You know, we are trying to interpret the music through the code that the live code musicians actually typing on the stage. But AI also could be a part of it, and there are musicians already embedding AI systems into their own practice. But I think there is not really like one answer to this question. Yes, we experience this world with our bodies, and technology plays a very crucial role. We look at the world through the technology, and we look at the music. You said electric guitar is at home. Like we look at the music through electric guitar as well, so that AI will find itself the way that you look at the music through AI. And if the embodiment is actually plays a crucial role, I'm sure that it will find its own place. But I don't think that there could be like at the moment a single answer to that.
I think we have time for one more question from the audience.
Hey, so this is something I've been thinking about a bit lately, and I have no idea if Marco is still watching on the stream, possibly. But I was talking to him about it, and I can't help but feel like the story, like the sort of dichotomy between academic and industrial, or academia and industry when it comes to learning is more complicated.
Oh. What is that?
Far away. Oh, too far away. Anyway, it seems extremely sort of paradoxical to me because it seems like there wasn't really a very, there weren't like two parallel research cultures, one industrial and one academic. They just kind of started hiring all the academic machine learning researchers like 10 years ago, right? And paying 3 times as much to spend twice as much time doing research. And also, paradoxically, like, I think academic machine learning's an extremely open, like one of the most open academic fields. Like, it's wild how any significant paper gets published on arXiv. It's all open access. It's extremely common to have open source software and model checkpoints, even the ones coming out of big tech companies. And similar story for sort of like the triumph of open source. So it's like very paradoxical how it's so open yet also so dominated by industry. And similar story for the data too. Like this is all surely driven by big tech companies' intention to use their proprietary data to extract value. But at the same time, the most important data sets, because of the open nature of research, are the enormous ones that come from the public internet, like like the Pile and ImageNet and things like this. So I just wonder if anyone wants to comment on that, on this kind of strange paradox.
Well, I think you've named pretty well the paradox, but I think that beyond the open culture around it, it's still the problem is still the data and the interests that are driving the development. So, like, industry is interested in developing certain kinds of algorithms, and it's great that they publish them and make them freely available. But it also means that they're not interested in developing other kinds of algorithms and that would serve the public. And we're talking about, I mean, well, and there's the data too, because I mean the data that we have, even the data that's publicly available. And I'm not so sure about what you're mentioning about well, maybe I'm not aware, but I don't think that the data sets like ImageNets are the biggest that there are there. I mean, like, the thing is that Meta and Google have their own data set of, and it's not just images, it's like data about social data, and that's not something they share, and we don't know how much data they have, but they certainly have like a lot, and it's one of the reasons why people want to go to work with them. It's also because they have access to all this data they can work with. And I think that the only there's an innovation problem related to that, and there's an economic problem. I think this is beyond kind of, this is it's a political problem. Like, these companies have to be regulated. They have to be forced to share their data, because otherwise it's and it's part of antitrust law, because they're using this as a leverage to other things. It's a bit like, it's like the phone companies. I don't know how it is here, but in Canada, the phone lines, the big phone company who put all the lines is forced to share the lines with other companies to encourage competition, and the same has to happen, I think, with data, but this will take a lot of time to happen. And then there's also the computational resources that not everybody has access to the same resources. So there is this discrepancy, and the issue again is that it remains that the business of these companies is, for the most part, they are into controlling people's behaviors. That's their business. It's advertisement. So I'm not inventing that. It's like 70 to 80%, I think, of their business, and I think for Meta it's a little bit more than for Google. They wouldn't make as much if they did not also operate in these other sectors, but it remains that this is their core business. And the data, the motivation for them to develop all these systems is to find ways to identify, track, and change the way that people behave. so that they can, and you know, it's also, we saw how much damage this did. Even the people who were working on these algorithms did not see that, you know, if you use this, the scary part about the art is this optimization thing. It's like you start optimizing one thing that you often use as a proxy for something else. So you're like, oh, let's optimize the behavior of people to engage on the platform. But then you get fake news, right? Or you be like, I'm gonna sell advertisement to whoever is buying. Turns out that, you know, Russian spies or Russian trolls are buying advertisement to send fake news and turn out the elections. So and these are considerations that the business sector has. They are actual problems. They're important problems, and they don't really know how to sort them out, I think. So. And you know, so maybe this is one part where it's definitely part where the civil society and where I think artists can act. I think artists can act in at least two ways. The first way is, like I said, to kind of reinvent ways to, but also the other way is that they're really good at democratizing things. You know, like, I mean, we were talking about Arduino.
Yeah.
And this is a really good example because Arduino. You know, it came from these maker creative communities, and then nowadays it's like there's a lot of people use them to do whatever. Like you find videos online of a guy in Texas just using this to control his farm, or you know, like all kinds of like people hacking into these things and making all kinds of creative things, and so it democratized this. Technology which used to be very closed source and proprietary and inaccessible. So hopefully maybe we can contribute to making this more available to the general public and create and distribute algorithms and approaches that are not about, you know, that serve other needs.
Thank you, Sofiane. Unfortunately, we're running out of time, so we have to leave it here. So. Thanks to all the panelists, Sofiane, Koray, Sarah, Alexander, and Benedict.
Very nice. Yeah.
And I think now I can pass the mic to the mastermind of this workshop, Chari.
Thanks, everyone. Yeah. Well, I will not keep you more. I know that now everyone quite tired and exhausted already, but and thirsty. Yes, yeah. We're gonna get there. Just a little more. I just want to say one very short thing regarding also the theme of this panel discussion, and also the same question I asked the same question in the beginning. This how can we make music with AI? And I just want to say that it's almost a little bit of a rhetorical question because, you know, a little bit of also inspired by how Sarah was taking out some words from the name of the workshop. We can actually take out the AI part and we can just ask how can we make music in the future as the question, because that's the main question. AI is just a concept that represents a collection of methods, but more than, you know, it represents new approaches. And for instance, like in this workshop, pretty much everyone who's creating new systems of AI, they emphasized the aspect of surprise, the unpredictability, which tells me that this is a depart from this old notions of composer's genius, the virtuoso, you know, like it kind of tells me that we're moving towards something different. It was also the same actually in the beginning of 20th century, right? So the first cybernetic artists, they were emphasizing the same thing. The futurists, they were emphasizing similar things, right? And to me, everything boils down to what Edgar Varese says, you know, how we need new instruments very badly. So it's a question of like how we're gonna make these instruments, how we're gonna use our body, in what ways our expectations will change. You can also ask like, how we're going to listen music in the future. Yeah. So I think it's a quite an open question, and now connecting this to this workshop, that's exactly what we should do, especially when we consider this paradox between the industry and research and accessibility of things. This is exactly why we should get together like this more often. Everyone should get their hands dirty, no matter what their background is, no matter what, if they can be engineers, there can be musicians, there can be researchers, or just, anyone. So that was the starting idea of this workshop. So this is why now I'm going to make a series of thank yous. So it can be it can take a little bit of time. Okay. Because even though it's kind of being called as mastermind touches my ego, but I'm not the first one. But first of all, as emphasized by many people, agency or creativity is a social and cultural notion, right? And it's not for machines only, also for humans it's a social cultural notion. We cannot be creative isolated from outside only by ourselves, right? We interact, we inspire by each other. So this is why I think we need interaction to share, learn, inspire, and so on. So maybe also a little bit of you can call me a little bit naive romantic, but I kind of always remind this nice Pink Floyd song, saying how divided we fall, but together we stand. So that's kind of the main starting point of this workshop. Okay, so then first, starting from here, I will start thanking our keynote invitees and our and panelists here. I will start from there then. Sofian, Koray, Sarah, Alexander, and Benedicte, thank you. And Stefano, thank you. And then our chairs, starting from the beginning, Peter Edwards, Karsten Krivots, Dan Overold, Kire Glette, Nanette Nielsen, again, Alexander Jensenius, Tejasvini Kalkar, thank you all. And for the pre-workshop hands-on, thank you, Bilge, Serdar, Göksuluk, and our tech crew. They really hide it in the back, but maybe you didn't realize, but a hybrid, this kind of hybrid event is quite hell. And it's been quite smooth, so far. And this is really the result of this tech crew's effort. And Alexander Tiedemann, Ose, Pedro, Maham, Björn, and all these MCT students, I think we should really give you an applause. It's really thank you. And also the administration, of course, they're not here right now, but maybe they can hear somewhere. Eric, Marit, Julie, they're all everything we eat, we ate, we drank, all these regulations and everything. So it was by the help of them. And of course, first and foremost, the Department of Musicology, Department of Informatics, and RITMO Center. Thank you for everyone, and of course all the presenters and the audience out there on the internet. So please, sorry if I forgot anyone's name, but I hope I did not. So thank you, and yeah, see you next time.